Hey, hello, engineers, and welcome back to yet another episode in the DevSecOps series, or let's say the AI ML security and governance series, in which today we are going to learn about the top 10 security risks that are associated with machine learning and its associated technologies. So, let's begin with what we are going to discuss in our today's video. First of all, we will really start with the basics, in which we will deal about what is machine learning and what is a model, which is the base of this machine learning technology, and how it is created. Then we will see what are the different attack surfaces that you can find for machine learning technologies, and then the core security objective that we as security engineer have to plan for these technologies. Then we will learn these security flaws that could arise when we are developing models or these machine learning algorithms and patterns, and then we are feeding data to it. And then once we know what are all of those, we will see some differences between data and model poisoning, and then we'll learn the machine learning security defense in depth approach. We will see what are the different layers that are supposed to get affected with this security flaws. Then we will learn about a mature, I mean, what an organizational maturity model looks like for security testing of machine learning products that they are developing. Then we will learn about what different controls we can implement, and then we will also learn what is a secure ML development lifecycle, and then a couple of tools that would help us um, in testing our models and then data, and then a lot of different things. So let's begin with the uh, first topic, wherein let's see about what is machine learning. So uh, you might have heard a lot about artificial intelligence these days. So, artificial intelligence is something where we want to mimic the intelligence that humans have, but this intelligence is to be mimicked by a machine. So, what artificial intelligence does is it's just replicate what human capabilities can do. Let's see, for example, vision, like we have eyes to see and recognize certain elements. So let's say if I show you a dog, you know how it looks like. It has four legs, head, it walks on its four legs, and it has tail, something like that. There are certain features that this dog or the object of dog is associated with. So you have seen that thing, and then that's how you have learned it yourself. So the same way, if we want to ask a machine to determine what object is it when we show it a dog, it should be able to answer in such a way that it is a dog, or it is a cat, or is it an elephant. So machine learning is a stuff where we train different compute mechanisms to determine certain things. So what we do usually is that we enable computers to learn patterns from data that we are going to feed it. And then once that data is stored in that particular machine learning model, then what happens, it is able to make predictions or decisions without being explicitly programmed for every situation. So once you show it a picture of dog and ask it what is it, it would give you the answer without any interruption or human need to be programmed that this is a dog or a cat or something else. So do you get the gist of out of it? Is like l- training a machine to function as humans. So that's what basically it means. So then, what is a model in that particular case? If we talk about machine learning, then there should be something that we are going to train. Okay. So the thing that we are going to train is called as a model. A model to do some, so let's say a model to do mathematical computation. So what we are going to train it on? We will be training it on mathematics. Again, another, let's say, a model which is trained in recognizing different types of cars or vehicles. So that model is going to be trained on that particular pattern. Okay, we will show it a different or 1,000 kind of vehicles, and then we'll ask it to determine what type of vehicle it is. Does it fly? Does it go by road? Is it a vehicle that runs in water? Something like that. So that's what we do when we talk about model and when we talk about training it. So machine learning model is a computer program or a mathematical function trained to recognize patterns in data. So what is data? Data is whatever we will give it. Okay, and make predictions or decisions on new unseen information without being explicitly programmed for every outcome. So how a compute program is supposed to recognize different things only when it has certain data, and how we are going to give that particular data to it. So that is what we'll first of all see, where we'll learn about how a model is created. So model has four different things: an algorithm, or a training data, training process, and the model. Okay. So what happens is the foundational set of rules or mathematical methods used to process data. So what we give, let's say we want to feed certain text to a compute program and then ask it to store that particular text. So then once that text is stored, we will ask it, hey, what do you know about, let's say, India? And then it will give us the information that it has in its data set regarding India. So if it does not have any data regarding India, it would give us like, I don't know about it. Okay, what is India? It is the first time I'm hearing this word. Please tell me more. So it means it is asking for us to train that particular algorithm or model on the data of India. So that's why uh, algorithm is the very basic stuff which kind of is used to process certain type of data. So let's say if it is a text data, it would be tuned to process different texts. Okay, so it would be English, it would be any other language. Okay, so an algorithm is must. Then the training data, wherein the training data should be a large collection of examples which are to be fed into the algorithm. So let's say you want some model to be trained in Harry Potter's questionnaires. Let's say if I want to ask it, what is that, sorceress apprentice, something like that. I don't know. That is a different thing. But if you want some model to give answers perfectly to the question someone asked regarding Harry Potter, then you will give the books or the data or the text that is there for Harry Potter. And once you feed all of that data into that model, then it would find out answers and give you the answers accordingly. So then once we have these two things, one is the algorithm, another one is the training data. Then what is the training process that you would adopt to feed data over a period of time to this model? So the algorithm adjusts its internal parameter, or what is called as weights and biases, to minimize errors and map inputs to correct output. So now you see, let's take an example of a child. So child has many teachers. Okay. So what it does is it kind of, the child sees the people in front of it, how they are walking, how they are talking, okay, in what language they are talking. And then he also sees the gestures that you do by hand. Let's say someone says like something like this, then he automatically gains the insight that this means to stop. Okay. And this means to eat. This means, this kind of gesture means to drink something or to ask for some drink. So that's how, the training process of a child works. The same way, let's say about the child first. So he learns multiple different things over a period of time. Now he corrects some things. Now he forgets something, or he kind of has different mechanisms to show a single item. Okay, a few different ways to show some single thing. So the same way goes around with the models that we are going to train. So this model then kind of adjusts itself internally, and then based on the data it is getting, it kind of trains itself, and then that training process is overwriting the new data. Then it should be again you know giving out accurate answers once it have more data. So let's say if we talk about something, let's say about global warming. So now people used to earlier say that global warming is only about cars emitting carbon dioxide. Then some people said, oh no, it's not just one thing, it's also the emission that is coming out of factories. Then again people say, oh no, it's not just that thing, again the chemicals that are there from the refrigeration machines, they also kind of emit certain things that causes ozone layer to deplete, and then hence global warming is increasing. So this information as it grows is the same way that model is trained. And then now if someone later asks it like, okay, give me few reasons of global warming, then it would list out these 5 items that we have fed it over time. So that is a training process, okay, that the model has to adjust to, and then the final model that it's created. So it is trained. Okay, the final trained output file containing the learned rules and mathematical relationships ready to process new data. So that is a model which now we will just give it all the data with the set of algorithm and the process to feed or ingest that particular data, and then it would give us the answer in a certain way. So that is what a model is all about. So now we have just covered the basics of what is machine learning, what is a model, what is training data, and what is the process of training that particular compute program or algorithm. So that is what will finally give us the model. So next is, what are the different attack surfaces that are correlated with this process of machine learning and training these algorithms and creating a model out of it. So machine learning systems introduce security risks that traditional applications do not fully address. So the very first thing is the training data sets. So the more inaccurate your training data set would be, the more inefficient or misleading your models would become. So imagine there is a model, a vision detection model who has, I mean, which has the capability to see things and recognize them. So now, if you train a model with a malformed data set showing the image of dog and addressing it as a cat, okay, so the more you give wrong data, the inaccurate the model would respond. So when someone asks him or it to show cat, then it would give out the picture of dog. So that's how training data could be one kind of attack surface where whoever is training that particular model, if somehow the data set is getting tampered or attacked by some malicious actor or an adversary, then the data set and that is there is getting corrupted, and then it reflects in the models, and then the model would give out false information. So let's say if you ask ChatGPT about different countries, now the data that is fed to it could bias its opinions about that country. So depends where the training data, I mean where the model is being trained, by whom it is being trained, and what type of biases it is giving that model. And then once people from different places consume that thing, they would get differentiated opinion on this particular information they will be getting out of it. Then the attack surface could be data pre-processing pipelines, wherein we gather data, we store that particular data somewhere in database, and then we kind of normalize that data, we kind of label that data. If that pre-processing pipelines are attacked, then that could be a major stuff. So someone can add some data while the data is being processed in these pipelines, and then it could be something else or something more that is not at all required. So imagine if you went ahead on Google and asked, oh, okay, I'm having this problem, or these symptoms. I'm getting yellow skin, I'm getting red eyes, I'm having fever, I'm having a running nose. So the disease or illness that you might have could be temporary. But then if someone have I mean a Google page where it says that if you have all of these symptoms, then you could have cancer. Okay, so that is a misleading information or inaccurate or something like that. Okay, so if data is been corrupted or data is incorrect, then that would lead to someone misinterpreting the actuality of the information. So then that person may get scared about the situation and he might visit doctor. There could be financial loss, there could be mental pressure, mental stress, and he might uh, get worried about his current health situation, and then uh, from that point onwards the health might get degraded more than he would have thought about. So there are a lot of implications of giving out data and having it consumed by someone who is requesting that data. So then there are different feature stores that are associated with the machine learning algorithms, and then that those could be manipulated, and then the features could be misleading uh, and kind of inaccurate in that way. So then ML models and model weights. Weight is something wherein it is a correlation between two tokens or two items that are there in the training data set. So if we manipulate these weights, then the accuracy of the answers get changed, or they get what we say disturbed, and then it results to inaccurate answers. Then model registries. This registry is a place where this compute data is being stored, the model is stored, and then what we say, if someone gets hold of this registry and it has a bunch of different models in it, then someone can change that thing over there, and then once that registry is tampered or uh, compromised, then it could lead to deployment of bad models that are not supposedly to be served to the customers. So we will see about it in further like, I mean the topics. Then the training infrastructure that you have, the ML APIs and inference endpoints, third party models and libraries, and then ML ops pipelines. These are the different attack surfaces you get to see in your machine learning development life cycle. So then just remember this thing as a mind map wherein you can say like input is one attack surface, then the data that is stored is again another attack surface, then the privacy of data or it getting leaked is again one concern for us, then the model, the supply chain, and whatever the output that it generates are different attack surfaces that we get to see in machine learning case. So we can differentiate all of these into different layers, wherein first of all we will talk about data layer, then model layer, infrastructure layer, and API layer. Okay, so what type of attacks could be possible on these different layers? So data poisoning is one stuff, data tampering is another thing, privacy leakage is again one stuff when we talk about data. Then on the model layer, we can see model could be theft. I mean, someone can steal that model, wherein we can have certain trained model and someone could just, you know, steal that thing and that functionality from us, and then we will not have a competitive edge in the market. So that could be a business loss for someone who is kind of building something from scratch. So that's why model theft is one thing. Model inversion, then model poisoning is again another thing. Then infrastructure layer could be a pipeline compromise, container compromise, or secrets getting exposed. Then API layer could be a model extraction, adversarial inputs that are fed to the model, and then the model behaves in certain way that it is not supposed to do. And then someone could abuse these different APIs or model APIs. So these are different attack surfaces that we get to see. Now, what is our core objective behind all of this? What do we want to achieve? We want to achieve confidentiality, integrity, availability, and then trustworthiness amongst all of the other things. So, what is confidentiality? It is to protect training data, model parameters, intellectual property, and sensitive predictions that we are supposed to do using these different models. Then, integrity of data is that to prevent manipulations of data sets, models, and prediction results, so that someone could not be able to manipulate these things, the models, and whatever the outcomes of that particular model are. So it should be the same. It should be not tampered with. It should not be misleading, something like that. And then the availability is like protect inference and training infrastructure from abuse and disruption. So disruption, it means if someone floods your model with tons of requests, then it could get um, overloaded with a bunch of fake requests, something like that. So then once it is jammed, and then the users who have paid for the service, they come in and they ask some information, then the compute mechanism would be stuck in serving some false requests. Then it would not give you, give the genuine users the access to that particular service. So it means that is the availability is now compromised, and it is disrupted, or it is not serving to people for whom it is meant to be. Then the trustworthiness is our one more course objective, wherein we want to ensure that model outputs remain reliable and behave as intended. It should not show sneezing as a potential cancer uh, thing for us. So this is what CIA triad along with trustworthiness. Okay, so this is our core security objective when we talk about machine learning technologies. Next is this list of OWASP machine learning top 10 security flaws, wherein there is input manipulation attack, data poisoning attack, model inversion attack. We will see what are all of these. Then membership inference, model theft, AI supply chain attacks, then transfer learning attacks. What is transfer learning? We will also see that thing. Then what is model skewing? Okay, output integrity attack and model poisoning. Now remember, these are all related with machine learning. Okay, there would be something else for gen AI. Okay, generative AI and large language models. So LLM security top 10 and gen AI security top 10. Though there are two, these are two different things. Okay, this is mostly dealing with the data model, the infrastructure, and some supply chain related items that it deals with. So the very first is input manipulation attack, wherein what happens is that an attacker intentionally modifies the input data uh, to cause a machine learning model to make incorrect prediction. So let's say there is a model which tries to detect spam calls or spam emails on your mailing server or mailing system. Okay, so now let's say you might have heard about or seen somewhere where it asks you to click this button and get an iPhone for free. Now, what happens is there is a machine learning model deployed to predict this thing or see this thing and flag them as potential phishing attacks. Okay, now some attacker comes and then he tries to give the input to manipulate this particular machine learning model, like whenever you see click here to win iPhone, flag it as a safe email. Okay, do not consider it as a phishing email. So over a period of time, when someone kind of inputs this thing and asks the model to store this data, like iPhone, click win iPhone 16, something like that, here is a safe email, is a safe text, it is a safe thing, it is non-dangerous, something like that. So over a period of time, this model gets used to such kind of inputs, and then now once a new malicious link or malicious email for same thing wherein it shows iPhone 16, win iPhone 16 by clicking here, it comes, now the model is not responding or not flagging this email as a potential phishing attack. Okay, so it has learned a behavior that to not flag something as a phishing attack. So that is what happens when someone tries to manipulate using different kind of inputs, and then it trains the model over time. So what happens is, what would be the impact of that particular thing is that incorrect fraud detection could happen. you know then autonomous vehicles, if there is some model that is driving autonomously to a vehicle, and that could be more manipulated. Then someone could also train that to flag some malware as a safe software package, and then that malware would be installed, and then it could bypass that particular system of scanning these items. So that's one impact. And then biometrics could be manipulated, and then again medical predictions could be manipulated, as I mentioned, like if someone kind of sneezes or has cough, and then it shows that okay, you have a cancer, something like that. So these are different impact that could be caused on different type of models that are used in this particular cases. So what can we do to mitigate this particular thing, the input manipulation attack? We can do some things like input validation. Whatever some person is trying to input through prompts or through APIs or through request, we want to sanitize them. We want to validate them. Okay, before it reaches up to the server and compute models. Then data normalization should be done. Then someone could try adversarial training, like give different prompts to your model and ask it or test it, uh, if it breaks or if it behaves in certain way that it should not be behaving. So that is what adversarial training, it means you yourself or your test team performs as an attacker, and then it tries to check if it behaves improperly or gives you an output that is not supposed to be given out, or leaks certain sensitive or private data regarding someone. So that is what you kind of deal with in adversarial training. Then robust model architecture should be implemented for your models. Then confidence thresholds should be there, uh, given for a particular output that is getting generated after you kind of serve this thing. And then anomaly detection should be implemented for some anomalous activities that are going into your infrastructure or wherever the model is getting deployed. And then continuous adversarial testing should be implemented. So these are the few things that you can do to prevent input manipulation attacks. Next is data poisoning attack, wherein what happens is an attacker manipulates the training data set, as we earlier discussed, so that the resulting model learns incorrect or malicious behavior. Okay, so if you ask some model to install a Python package, let's say uh, on your machine, or it is generating certain code. Now someone could hack the data set or kind of modify the data set to also download a malicious executable file or malicious package. And then what would happen is that once it is on your computer, then it would cause behavior that is not supposed to be there on your laptops. It could create a reverse shell, a backdoor in your application or your laptop that would give access to attackers to your system, and then it could be compromised. So this is what happens when you deal with coding models, let's say Codex or OpenAI Cloud, something like that. So this is pretty much it happens in regular days. These days. So you might go on internet and try to search certain examples. You will get these kind of things. So then what is the attack flow? The attacker injects malicious sample of data in the training data set, and then the ML training pipeline grabs that thing, and then it creates a compromised model which have this malicious file samples or example samples, something like that. So what it could potentially impact is it would reduce the prediction accuracy for whatever the model is being generated. It could bypass the security controls that are implemented by your organization or for your personal um, use as the matter. Then there could be hidden backdoors. As I mentioned, someone could create reverse shell program and then add it into your model, and then it fetches that thing, and then that would you know give access to your laptop to people who are not supposed to getting this thing. Then biased models could be there, and then fraudulent recommendations. So you might have heard about some models recommending certain objects or certain Amazon product for some queries. If you ask, okay, how do I grow a rose plant in my backyard? So they would say, like, you need to purchase it from this shopkeeper, or you need to have the seeds, you need a urea, you need these fertilizers to be used from this particular person who is selling it online or offline. So these kind of fraudulent recommendations could be there if there is certain model that is being used by consumers. Okay, so how we can mitigate that thing? So very first of all, we would like to implement dataset provenance. Provenance, it means keeping a record of something on how it have generated or modified in its past. Okay, so trail of events that has that this particular thing has gone through. Okay, so you know independence was a result of different events that occurred in the past. Okay, so right before 1947, there were a lot of different things that happened in 1929, 1990, 1920, 1905, that led to the Indian independence. So this is a kind of provenance of how things have gone through over a period of time. So the same way, the data set should be also keeping record of the history and the changes of all of these things have that it has gone through, who have modified it, when it has been modified, and what has been modified. Okay, the same way git is for code, it should be the same way for data sets altogether. So that is what dataset provenance, it means keeping a history record or track of the changes, who made it and when they were made, and then how they were introduced, where they were introduced in the dataset. So that is what is the very first thing. So that now like only people in our organization have trained this dataset. No other people or no other person from outside has tampered with this data. Or if the data has been tampered, then we would know like when it happened. Then we would go back to that thing, erase that thing, and then move ahead in that particular dataset provenance. Then dataset validation is one more thing. You need to validate your entire dataset if it is not having any certain stuff that is required or not. Then outlier detection, you need to again detect some data that is not supposed to be there. It's the same thing that we do with in case of validation, is to detect outliers. Then training data access control, you need to implement DAM solution, which is kind of database access management kind of thing. Okay, so that's one. Then dataset versioning, you need to provide or preserve the versions of data that is getting trained, and then you can roll back some stuff sometimes. Then statistical monitoring should be done, and then you should make sure that you always use trusted data sources to train your models. That is one thing. Next up is about a model inversion attack, wherein what happens is an attacker analyzes model predictions to reconstruct sensitive information about the model's training data. So what it is doing is reverse engineering the training data and grabbing out sensitive information on what training data is being used for this particular model. So let's say consider a facial recognition model. This is an example. Now an attacker repeatedly queries the model and uses prediction probabilities to reconstruct characteristics of faces contained in the training dataset. Now once it is kind of able to build that those faces, it can now determine which people are these, and then he can search it online or somewhere else for this exposed data. Let's say it is of some scientists that we have. Then you might have heard about another country which tries to deploy spies to kind of lure these people into honey trap. Okay, and then these scientists get these people get very closely intact with these particular people, and then uh, certain data, confidential data regarding certain project is getting leaked somehow. So that is what it is, a kind of exposure of this mechanism. Okay, some model inversion stuff that someone could back propagate and train or kind of extract certain information that is required by them. So information potentially exposed is kind of faces, personal information, medical information, financial attribute, and sensitive demographic attributes. And then these could be used to attack in certain countries and then certain cases, something like that. Okay, so what is the impact of that thing is first of all, privacy could be breached of people. Then their data could be lost and given to certain malicious actors, and then they could misuse it to harm them or kind of destroy their financial accounts, something like that. Then regulatory exposure could be occurring due to this thing, and then loss of trust in a particular system could be there. And then once a system has lost trust in it, then it loses its business and its people. So what can we do to mitigate it? Is it differential privacy is what we can apply to that particular training data set, wherein we would say like do not recognize this particular people, or give certain what we say masked data, or some only bits and pieces of data to not have someone reconstruct the entire information. So that's one thing. Then reduce prediction confidence exposure, so that someone if he or she got the access of this confidence prediction confidence data, then they could be 100% sure about the accuracy of the data that has been fed to it. Then restrict the API access to certain things, and then rate limit that thing, so that someone could not repeatedly query this data for query the model for that particular training data. Then query monitoring, what is the query that is being fed to the model, that is what you can do. And then data minimization is one thing, and then privacy preserving machine learning techniques could be there. You will see different tools that would help us achieve that thing. So data privacy is one more important stuff, which is what we would be addressing due to through this model inversion attacks. So then membership inference attack is again one more thing, wherein an attacker determines whether a particular record was used to train machine learning model. The same way, now it would ask it, okay, let's say an attacker queries a healthcare machine learning model and determine that a specific person's medical record was included in training dataset. So what happens is that when you have this model, and then there are certain attributes that are given out. Now what you will do is, now you will ask model is, was this person's data used because he had the same kind of attribute that you have just mentioned over here, and then is it correct or not? And then it would give information, yes, I have used the data of this person to train myself, and then someone could be sure about that thing, and then that record could be again misused, or you know they could find out then if this person's data was used, then again another person is associated with him, was his data also used. So then you can find out a chain of training data sets that were involved in your findings, or in your training phase of that model. Now why it works is that uh, models that overfit training data often behave differently for training samples compared to unseen data. So what happens is that if you have only trained a model to work on predicting dogs, then if you kind of give it a photograph of cat, then what will happen, it would not recognize that thing. So that's why overfit training data in one particular case leads to incorrect behavior, okay, of when introduced unseen data. So that's why membership inference kind of attack is very dangerous for the data set that is being used for training this thing. So then what it does is potential impact is privacy violations, disclosure of sensitive data set, membership, then GDPR, which is global, or sorry, not global, general data privacy regulation, then privacy and compliance concerns, then exposure of confidential training data set is what could occur due to this thing. Then what can we do to mitigate it? Again, differential privacy, regularization, prevent model overfitting to accustomed data, then limit confidence score, query rate monitoring, and then access control to different models and datasets. Next is model theft. Now, what is it all about? So, an attacker attempts to obtain or reproduce a proprietary machine learning model. It tries to steal what you have built with so much efforts. So how they can do is, there are two different approaches. One is direct, another is model extraction. So in the direct theft, what an attacker can do is, attacker might compromise your model registry, the place where we store our models. So let's say a Git for ML. Okay, then the cloud storage, or the machine learning servers and the CI/CD pipeline. He or she can compromise this thing and steal model.pkl, which is a pickle format file, then weights.pytorch files, or model.on and onyx, let's say open a neural network exchange format. So they can steal this thing and then again recreate the model, or you know reverse engineer this model, and kind of replicate that thing. So what happens is, then your we will see it in the impacts, that your intellectual property, what you have built with so much hard efforts, could be easily stolen by these people. So the same way, Nvidia is kind of creating a lot of this kind of thing. So we'll see it in some later video. Okay, someone says that, oh, stealing is very bad, then some another country steals your thing, then you say, oh, we were stealing it from product companies. Now another another organization or another country is stealing our thing. So then people ask, oh, why is it wrong? Because you are also stealing from us, they are also stealing from you. What's the point? So I hope you remember a meme that was shared a couple of weeks ago. So then model extraction is the another method wherein someone can steal your model, wherein attacker repeatedly queries an API where the input gives out your prediction, and then builds a substitute model that approximates the original. So it tries to feed it inputs, and then it sees what the output we are getting, and then he or she kind of tries to build the same thing, uh, for his own purpose. So let's say ChatGPT is there. You can ask it about a certain data. Let's say, tell me how to build a garden or how to grow some vegetables in garden. Then that information would be there in ChatGPT's model. Now, someone who wants to create another model with the same functionality of showing you or telling you how to grow your garden or how to grow plants in your garden, he can repeatedly ask ChatGPT different questions, and then based on the output that it is giving, it would copy and paste that thing and train its own model with those answers, and then it would replicate, or it would have the same kind of effect just as ChatGPT. So what happens is the intellectual property of ChatGPT has been lost due to someone kind of extracting the information from this model. So that's why model extraction is one more thing. Then competitive advantage loss is there, because if someone says, look, for gardeners, my model is the best, more accurate than ChatGPT. So the people who are looking for information on gardening would only go on this new model which has been extracted by from the ChatGPT system. So competitive advantage would be lost for ChatGPT. Then security controls bypass could be happening, and then training data confidentiality is at risk. So that is the impact of model theft. Then what can be done for mitigation is strong authentication for people who are only authenticated or allowed to use it. Role-based access control, then model encryption should be there. Someone should not be able to query this thing again and again. So API rate limiting is one thing you can apply. Then monitoring the queries could be one more thing, and then model watermarking, and then secure model registries is again another thing that we can do in order to prevent direct theft of models. So this was about model theft. Next is AI supply chain attacks, wherein machine learning model systems, I mean, sorry, modern machine learning systems rely heavily on external components. So libraries, third-party libraries, softwares, then Docker, Kubernetes, or EC2 instances, compute mechanism, something like that. So let's see what things are there in ML supply chain. Okay, so public data set is one thing. Open source libraries, pre-trained models. Like, we do not build anything, and most of organizations do not build anything from scratch. They kind of build it on top of some pre-trained model, and then they fine-tune it to suit their needs. So if something was there in pre-trained model, a malicious code, then it would be visible in your deployed model, and then it would be compromised. Then containers, machine learning pipelines, and then um, what's that, production models that are there. So an attacker may compromise any of the component in this particular chain. So that's why this is an AI ML supply chain. And then if an attacker compromise any one of these things, then your model would be at risk. So then potential attack vectors are malicious Python packages, the open source libraries that are consumed, compromised machine learning libraries, Trojan pre-trained models. So there is a Trojan attack you might have heard about, that something is there already inside that horse, and then it is entering into a castle, and then in midnight it kind of bursts out. So Trojan pre-trained models for softwares that are already present in pre-trained models. So that's why large organizations should be focusing on uh, creating models from scratch and do not use pre-trained models, mostly open source model. So untrusted data sets, then malicious containers, dependency confusion, and then compromised model repository. So these are the few things where someone could attack on your AI supply chain. So next is how we can mitigate these things is using signed models and artifact. Using SBOMs or AI bombs is bill of material that we usually see. Then dependency scanning should be done, dataset provenance, as we discussed earlier. Model provenance should be also done. We should know how this model has been evolved over a period of time. It should have the history, entire history of its origination. So model provenance. Then container scanning should be done. Trusted repositories should be used. Hashes and signature verification should be applied when we deal with signed models. And then CI/CD security control. So these are the few things you can do for it. Next is transfer learning attack. Now, let's say what is transfer learning first of all. So instead of training a model from scratch, as we earlier discussed, large organizations kind of try to build on pre-trained model. So instead of training model from scratch, organization usually prefer pre-trained model and then fine tune that thing and then declare it as an organizational machine learning model. So what is the security risk associated with it? Is that if the base model has been maliciously modified, have any hidden behaviors, and like they which can survive this fine tuning, so it could lead to persistent model backdoors or incorrect classification and then supply chain compromisation or difficult to detect malicious behavior. So what happens is if you use something that is already available and then it had certain malwares or kind of backdoors that could be invoked using certain queries once your organization's model is online, so that could potentially breach through the entire infrastructure and give out sensitive information, or could be also used for cryptocurrency mining activities. So that is a risk that you can have by using pre-trained models. So that's why we always say do not use pre-trained models. You can only use them if that is required on a given basis, but you should always prefer building something from scratch. So how we can mitigate that thing is to use only trusted model repositories. Do not go and pull anything from Hugging Face or Olama. Some things might have, uh, you know, uh, compromised models, base models. So verify model provenance, as we already discussed. History of models should be, verified. Then scan model artifacts. Then benchmark before fine tuning is like you should be hardening this thing. You should have CIS benchmarking for models, and then perform adversarial testing before you go through it. And then test model backdoors, and then maintain model hashes and signatures. So there could be a couple of tools you can use to determine these things, which is what we'll see in some later slides. So that was training, learning attack. Then comes model skewing, which is like an attacker manipulates the environment or inputs over time so that a model gradually produces biased or incorrect predictions. So recommendation engines, fraud detection, search ranking, credit scoring, advertisement systems, and content moderation. These are the few things that someone could train its environment. The model's live environment should be or could be manipulated to kind of generate false recommendations kind of thing. So earlier you remember if we discussed about some gardening example. So a model that gives out information, okay, purchase this fertilizer from this vendor from this website. That is the kind of recommendation that it gives, which had been trained by model skewing, or manipulating the uh, you know models training data, and then over a time it kind of produces that biased information, and then it says like, oh, no, 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 this supplier is bad, this supplier is good, this is the price range is higher, but even it is good because this is a trusted supplier. So that's how it kind of biases the recommendation engine, and then it kind of does certain fraudulent activities. So that's what it is doing. Potential targets are this kind of uh, things. So someone modifies its credit score and then gives you a high credit, and then you derive loan, um, even if you are not eligible. So that's why credit scoring could be manipulated. Then what is the impact is biased decisions, fraud, manipulated recommendations, reduced model accuracy, and business losses for other people that are not using model skewing methodologies. So data distribution monitoring should be done. Drift detection should be also done, so that people, or you would get to know, like if your data has been changed or if your model has been changed. That's why you have to do the drift detection. Next is prediction monitoring, then baseline comparison, and then model performance monitoring and human review for high risk decision is also one more thing you can uh, you know deal with in order to mitigate this model skewing. Next is output integrity. Now the video is long, that's why you can always uh, look into the mitigation strategies and the impact of the each and every security risk that we are kind of discussing over here. So next is output integrity attack. An attacker manipulates the output or prediction pipeline after the ML model generates its result. So what happens is user inputs something, then ML model performs some computation, then it kind of tries to predict, and then there is a certain business logic, and then there is an API response to it. So now an attacker compromises the integration between the model and the downstream system. So from model up to this prediction, business logic, and API response thing, those could be modified. And then actual model result of some fraud risk, recommendation engine is that some malicious emails were highly fraudulent. So that was its earlier trained data set. Now someone could modify that thing and say like, okay, now this iPhone buying email is a low risk fraud, but so it is not actually bad, it is safe. So that's how output integrity could be lost. So whatever output is, it could be incorrect. So that's why, what is the impact? It could potentially lead to fraud, incorrect automated decisions, security control bypass, manipulated recommendation, and loss of decision integrity. So if someone is giving you fake information or false information, then that is output integrity attack. So secure APIs, TLS, mutual TLS, and then signed response, authorization controls, audit logging, integrity checks should be there, and then zero trust service communications should be established. So those are the few things you can use to mitigate this thing. Then lastly is model poisoning. So you know earlier we discussed about data poisoning. Now here it is about model poisoning. So unlike data poisoning where training data set was getting manipulated, model poisoning directly manipulates the model itself and its parameters. So OWASP defines model poisoning and manipulating model parameters so that the model behaves in undesirable ways. So there are weights. Weights is a correlation between certain data set, wherein if some weight is more with this related data, then it would kind of give it as an output. Now imagine if the weights have been changed, and then another thing is been more correlated to this thing. So let's say if I say word terrorist, now which country comes into your mind? Okay, that is one thing. Now if that weight is correctly associated, then it's fine. But then if someone transfer the weights to associate that thing with another country, and now you search for terrorists, then it is giving you a country which is not even dealing with terrorism. So that's what is model poisoning, is to manipulate the parameters or the correlation between these parameters, which are also called as weights. So trusted, first of all, weights are trusted. Then attacker gains the access to your model and then change the model parameters, and then the weights are getting compromised, and as a result you get incorrect information. So targeter misclassification, model accuracy is reduced, hidden backdoors are introduced, and then trigger based malicious behavior could be also there. So what we can do to mitigate this thing is to encrypt model artifacts. We can introduce cryptographic signatures. Model integrity checks could be there. RBAC for model registries. Then immutable model artifacts. Model versioning should be there, and then secure CI/CD and runtime monitoring should be applied or implemented for this different models, so that no one could do it on the fly. So next is what is the difference between data poisoning and model poisoning? We already dealt with it, but we'll just see it in very brief. slide. So data poisoning versus model poisoning. What is the target? The target is first of all the training data and model itself. So these are the different targets that we can see. Then where it can be attacked, what is the attack stage? So before or during training is what you can attack this or poison this data. And then a model poisoning could be done when training is done, deployment is done, or model is stored somewhere. What does attacker modifies the modifier? I mean, the attacker modifies the data set when we talk about data poisoning. It changes the data, and then here in model poisoning, it changes the weights or the parameters that are associated with this correlated data, so that it gives you incorrect information. Next is, what is the example of this thing? An incorrect labels could be attached and classified it as something else, and then here you could have modified neural networks and the weights that are associated. Then what is the primary control? We can manage and apply dataset integrity check, and then here we can apply model integrity. Okay, and then runtime behavior and all of these things. And how detection could be possible is like where we do the data validation step for the entire data set, and then if we found out that this is not some data that I kind of fed it, here you can validate that the data was tempered or poisoned. Then model or hash verification, you should be signing the models, and then it could be there in your registry, and then once you deploy it, you should always verify the hash of this model, and then if it is changed, then you can be sure that this model has been tampered with, or it is the same or not, something like that. So that is what model poisoning and data poisoning. And then you can have a mind map wherein you can bifurcate or differentiate between both of them. Is like bad data in the training is when bad data is included in training, then it creates a bad model. Okay, and then when there is good model and then attacker attacks that good model and it modifies that thing, that is called as model poisoning. So that is the difference between both of these. So this was all about the security risks that are associated, which were mentioned in OWASP top 10. We would again see uh, some stuff that is related with the security implementations for machine learning stuff. So machine learning defense in depth. First of all, think of ML security as multiple protective layers, wherein we would see layer 1, layer 2, and this is the same layer that we earlier saw when we were talking about ML attack surfaces, and then different layers about. First of all, the layer is first data security layer, wherein we would do the dataset validation, provenance of the data, and encrypt that particular data, wherein it should not be accessible by someone who is outside the organization. Then layer 2 is model security, wherein we would again have model integrity checks. We would also test adversarial robustness using different tools, so that models are not creating certain outputs that it is not meant to be done. So then model encryption can be also done, so that no one could get the model and then again tamper with it, or extract certain information from that model. Then layer 3 is ML ops security, is to create secure CI/CD, then artifact signing, and then dependency security checks for this model code or whatever we are using to build it. Then infrastructure security is like use IAM, identity and access management, container security, and then network segmentations to provide attacks availability, and then disruption of this particular infrastructure. Then API security, authentication, rate limiting, and input validation should be done over the API systems that we are using for these applications. Next layer is runtime security, wherein we would be more to focus toward drift detection, so that no one is kind of manipulating or changing your data set and model models trained behavior, so that it is not going to behave in certain way that it is not meant to. So that's why drift detection is really important. And then abuse detection, you can use runtime security tools to detect abuse or some backdoor entries or shell or system calls, something like that. And then you can monitor the outputs that it is creating. So monitoring should be done. And then governance is like you can do risk assessment and then apply policies, auditing and compliance regulations that you can see over there. So that is what these are the different layers that you can use to secure your machine learning models. Then there are different ML security testing strategies that you can use. So mature ML security program should test more than just the application code or the algorithm that is uh, associated with the model. So we can do data security testing, adversarial testing, privacy testing, model security, and ML ops security testing. So we can do poisoning simulations on the dataset that we have. Then dataset validation and dataset provenance and verification is what we can do. Then adversarial testing is like you can check evasion attacks, perturbation testing, and then adversarial examples is like you can try and attack your models for profanity or abuse language, or creating, if it is a generative AI, it should be asked to generate some thing that is unethical or something like that. So you can also ask it to execute sudo rmrf on certain sensitive file storage or file path or directory path, something like that. So you can try and use this adversarial testing tactics on your own ML models, so that you can more harden these things and then you can apply guardrails to secure it. Then privacy testing is like membership inference, just as we saw earlier. Does it give out information regarding to people and the data that it was used for? Then model inversion, is it possible or not? Okay, is data getting leaked? Some, if can someone extract the model? Model extraction attempt is to do for model security. And then backdoor detection, model integrity validation, and then for ML ops security, you can go with pipeline security, container dependency, and secret scanning. So these are the few things that your security program should involve on these different layers, as we discussed earlier. So what are the different control architectures that you can implement for it? First of all, on ML okay. On user application or API gateway, you should have authentication, rate limiting, and web application firewalls to detect certain kind of attack patterns. Then ML inference services should be having input validation, anomaly detection. Model should have integrity checks, sign artifacts. We have discussed all of this thing earlier in the mitigation section. Model registry should be having RBAC, encryption, and versioning, so that no one could tamper with whatever it is in the registry. MLOps should include SAST, SCA, container scanning, and model scanning tools. Then training environment should be having the dataset validation controls, provenance controls, and secure compute mechanisms. Then for monitoring, you can use model drift detection systems, and then API abuse and security alerting stuff. So that is how you kind of implement security architecture or controls around your entire life cycle. So now, how do we secure the machine learning development lifecycle? So security should be integrated throughout the ML lifecycle using following controls. So first of all, data collection. This is the ML lifecycle. Okay, data collection, data processing, then model training, then model validation, model deployment, and then runtime. So these are the different lifecycle. And then what controls or what things we implement in this lifecycle is what. First of all, in data collection, we would use trusted sources of data. We would review privacy for each data set that we have, and then we would keep a history of the data set. Then data processing, we would sanitize the data first, remove all the personal information and all these things. We would remove outlier, and we can detect that thing if someone has introduced something that is not meant to be there in the data set. So this could be addressed in the data processing phase. Then integrity of data should be there. If the data is correct or misrepresented, that is what we need to find out using integrity checks. Next is model training. So secure training environment should be there, access control should be applied, and adversarial training should be done, so that if adversary is attacked, then your AI model should stop executing such kind of attacks. So then model validation should be done. Red teaming should be there. I mean, red team should be there to test it. Then you should also test the robustness. Is the model going to be available, and is it non-disruptive, something like that? So it could test the robustness of this thing. And then privacy testing, if the model leaks certain private information, that is also you what you need to test. Model deployment is could be testing signed models and secure containers and IAM. Then on runtime monitoring, we have already discussed this thing. Drift monitoring, attack detection, and audit logging should be implemented for this entire life cycle. So these are the different security controls. Again, you can implement on these different layers in the development phase of your models. And lastly, we will be discussing about different ML security tools that we can use. So different security areas are there and different tools to address that things. So adversarial testing, as we kind of heard about it earlier. So IBM's ART, adversarial and robustness toolbox, is one thing which covers mostly a lot of things. We would see this thing in our later videos, how to use it. Then Clever Hands, Fullbox, and Microsoft Counterfeit. And then ML security and model scanning tools is Protect AI, Garak, Hidden Layer, Robust Intelligence, and Cisco AI Defense. This we would see Garak and ART in our upcoming videos. Then supply chain security could be addressed using SIFT, Gripe, Trivi, Sneak, and Cyclone DX for S bombs or AI bombs. Then ML ops or model monitoring, we will go with ML flow, evidently, Y-Labs and Arise. And cloud or runtime security, we would go with these of this. I mean, some of these things, which is Wiz, Aqua, Sec Security, Qualys, Falco, Prisma Cloud, something like that. If you are using, Kubernetes, it's for Falco. So these are the different, tools that you can use for your security of machine learning models. So that's all for our today's video on OWASP top 10 for machine learning security. And let me know, guys, if you kind of have discussed this thing with someone earlier, or if something was left out of it, or if you would like to see something more. We will be very happy to include all of these things. Next up, we are going to learn about OWASP top 10 for Gen AI and large language models. So bear in mind, like, these are two different things: OWASP top 10 for machine learning and OWASP top 10 for Gen AI and LLM. So today we have seen this thing for machine learning. Let's see the other stuff in some another video. Until then, leave a comment or drop a like if you like this entire video, and see you guys in next video. Till then, keep learning and bye.